Okay, students, so let us go deep into the chapter chemical kinetics. Let us learn something more. Till now, in till the lecture 2, you have learned what is rate of reaction. You have learned what is rate of reaction and how to express the the instantaneous and the average rate of reaction. Now let us learn how to express rate of reaction. Okay, how to express rate of reaction on the basis of concentration. On the basis of concentration. Now let us consider a reaction R to P. We have learned that the rate of reaction is minus of dr by dt. ROR, overall rate of reaction, is minus dr by dt. This is actually directly proportional to the concentration of R raised to the power n, and when you will remove this proportionality sign, you will have k here, k into R raised to the power n. Now this k is called rate constant of the reaction. This k is called rate constant of the reaction, and this n is called rate constant of the reaction, and this n is called order of the reaction. Now this, let us study about this rate constant. This rate constant k, this depends on temperature, which we will learn later on, and this will also depend on the reaction. Okay, we will study about the temperature dependence of the rate constant later on, and this also depends on the reaction. Okay, a reaction will have a different rate constant, so it depends on the nature of reaction and on temperature, and the order of reaction depends on the nature of reaction. Order of reaction depends on nature of reaction. Okay, this is also same thing. This also depends on nature of reaction. Okay, now if n equals to 0, then we will call it as zero order reaction. We will call it as zero order reaction. Very clear, right? N is 0, we will call it zero order reaction. If the value of n is 1, we will call it first order reaction. If the value of n is 2, we will call it second order. If the value of n is 3, then we will call it third order. Nth order reaction. Okay, we will call as nth order reaction. Nth order reaction. Okay, we have learned this one, that the name of the reaction will depend on the value of n. If the value of n is 0, then we will call zero order reaction. If value of n is 1, then first order reaction. If value of order is 2, then second order reaction. Okay, so this is the thing about a single reactant constituting reaction. Now let us come to a little more complex reaction which are having more than 2 reactants. Suppose 2R plus P equals to suppose D plus 4E. Okay, now here in this case ROR, we have learned before how to write ROR with the help of the concentration of all the constituents in average form and in differential form by delta R by delta T, change in concentration by time. That is the basic formula. But now we will learn to express with the help of concentration of reactants. So this ROR will also be K into first reactant R raised to the power N1, P concentration raised to the power N2. Okay, these two will be the order of the reaction. Overall order of the reaction, overall order of this reaction, overall order of this reaction will be N1 plus N2. N1 plus N2. Now, if this N1 plus N2 is 0, then we will call it a zero order reaction. If N1 plus N2 is 2, if N1 plus N2 is 0, then we will call it zero order reaction. If N1 plus N2 is 2, then we will call it second order reaction. If N1 plus N2 is 1, then we will call it as first order reaction. Then we will call it first order reaction. And this N1 will be known as order of reaction with respect to WRT, with respect to reactant R. N2 will be known as order of reaction with respect to P. Okay, so in this kind of reaction, N1 plus N2 will be the overall order, and N1 will be order with respect to R, N2 will be order with respect to P. Now students, it is very important to understand that this N1 has nothing relation with the stoichiometric coefficient. This N1 is no way related to the stoichiometric coefficient. Now let us come to an exceptional case. Okay, if this reaction is a single step reaction. Now I will go into this later on further. If it is single step reaction means the reaction takes place in one step. We know that there is a reaction phenomenon, there is a there is a process of reaction, na? That in organic you will study about those reaction mechanism. If you see into mechanism of a reaction, then there can be various steps of a reaction. But this, I am speaking about single step reaction. That means the reaction will have one step. The reaction will complete in single step. In such kind of single step reaction, the order of reaction with respect to a reactant will be equal to the stoichiometric coefficient. That means if this reaction was a single step reaction, then the value of N1 would be 2 and value of N2 would be 1. But this is only in case of single step reaction. Okay, so in case of single step reaction, what we have learned here, that in case of single step reaction, order of the reaction will be equals to the stoichiometric coefficient. Let us take an example of single step reaction. Suppose 2R plus B equals to C plus D is a single step reaction, then the rate of the reaction will be equals to K. R order will be the stoichiometric coefficient 2 and B will be 1. This is 1. This will be the order. So overall order of the reaction, overall order of the reaction is 2 plus 1 is equal to 3. That means this is third order reaction. Now the last thing of this lecture, when you write the rate of reaction in this way, it is called as average rate. It is called as average rate of reaction. Okay, if you write the concentration of reactant in this way, it is called differential rate. Okay, differential rate of reaction. And ultimately, if you write the rate of reaction with the help of this way, this way which we have learned, then this is basically called as rate law of the reaction. Rate law, okay? This is called rate law. So if in question you are asked, one second, if in question you are asked to write the rate law of the reaction, then you will write this way. If you are asked to write the differential rate, then you will write this way. And if you are asked to write the average rate of the reaction, then you will write this way. So this is the full three way of denoting the rate of the reaction. Now further into the chapter, we will learn about zero order reaction, first order reaction, second order reaction. We will learn about the rate constants, some more, and you are very clear with the unit of rate constant. Unit of rate constant will depend on the nature of the reaction, because for every reaction the value of n will be different. Whether if the value of n will be different, then the unit of this term will be m to the power n, right? And this unit will always be same, mole per second. So if you bring it here, the unit of rate constant will differ with the reaction if the n value is different. We will learn about that later on, and later on we will learn about temperature dependence, how the value of K depends on temperature, the Arrhenius equation, the collision theory. But before this, these are the basic thing of the chapter chemical kinetics, which you have to know for anything. It may be board, it may be competitive exams or anything. You have to learn these three concepts very clearly. Thank you. Be safe. Jai Hind.